In this lesson 2, we are going to look at graphical representation and solving equations with quadratics. Now, if I had to guess, I would say that you already know for a long time that if you are to sketch a quadratic, you will always do something like this or something like this. And this is called a parabola, okay? If you are to draw a parabola, if you are asked to draw a parabola, then you need to know some very important points that will allow you to sketch it. The very first thing that you need to know is to learn if the parabola that you are going to sketch is going to have this orientation, which are called a positive orientation, or this orientation, which are called a negative orientation. And to learn which one of these you'll have, you just have to look at the coefficient of x squared. If this is a positive number, then the parabola is like this. If this is a negative number, then the parabola is like this, right? You can see with this example over there. Then, other points that are very important are the x-intercepts, or the zeros of the parabola. What are these? These are the points where the parabola is crossing the x-axis. Now, you need to understand that you may have a parabola in which you don't have any zeros, and more on that in a bit. But how will you go and find the zeros of the parabola? Well, I have here three methods that they end up being the same. The solution must be the same. That's obvious. The first one is by factorizing the quadratic and equaling it to 0. If you can factorize the quadratic, you just equal it to 0, and this is going to be the simplest procedure, the simplest method. Look at this example. If you have this quadratic, you have to think of two numbers that added together gives 1 and multiplied together minus 2. These are going to be the 2 and minus 1. So you factorize this in a couple of seconds. And then if you equal this to 0, if you have the product of two things that equal to 0, this can only take place if one of the things is 0. So either x plus 2 is 0 or x minus 1 is 0, which yields x equals minus 2 and x equals 1. So these are going to be the zeros, the x-intercepts of the parabola. So you already would know two things. You know the parabola is like this, and you know that the points where they cross the x-axis have these coordinates, minus 2, 0, and 1, 0. You can get these numbers using different methods. You can just do the complete square form and then equal it to 0. In this particular case, to complete the square, I open the brackets, I write x plus, you have a 1 over there, I write 1 over 2, close brackets and square it. Then I remove this squared, okay, so minus 1/2 squared, that's minus 1/4, minus 2, minus 1/4 minus 2 is minus 9/4. So here you have the quadratic expressed in its complete square form. All right, I equal it to 0, I solve it, and obviously I need to get the same result as I got before. The same thing goes if I use a quadratic formula. Obviously the solution will need to be the same. Okay, so whatever method you pick to equal the quadratic to 0, you will have the values of the x-intercept of the parabola. Okay. Now, as I was saying a little while ago, you may have three situations in what regards the number of zeros of a parabola. You may have 2, you may have 1, or you may have no 0 in a parabola. If you have 2, basically you have a situation like this. You can sketch, if you plot the parabola, you'll have 2 points in which the parabola is crossing the x-axis, so 2 zeros. In what situation will you have only 1? That's when the vertex is on top of the x-axis. You have only 1 point touching the x-axis. which means that you will have no zeros if the parabola is all of it on top of the x-axis or all of it on the bottom of the x-axis. For these sketches, I could have written them as well with a parabola inverted negative, okay? The consideration is just the same. So how can you decide the number of zeros of a parabola? How can you figure out the number of zeros of a parabola? I'm not talking about figuring out the values, just the number of zeros. Look at the quadratic formula. In what situation will you have two solutions to the quadratic formula? You will have two solutions to the quadratic formula when this part over here is something. And by something, I mean a number. Because you will have a solution in which you use the minus, and you'll have another solution in which you use the plus. That's the reason why you have two solutions in the first place, right? In what situation will you have just one solution to this quadratic equation using the quadratic formula? This happens when this is 0. So it really doesn't matter if you subtract or you add 0. Your solution is just going to be minus b over 2a. You have one solution. They also call this repeated zeros, okay? So we have seen two solutions, one solution. What about no solution? This happens when what you have here inside the square root is a negative number. If you have a negative square root, and if you try to put that in your calculator, you'll have math error, which means that you won't find any solution to that equation, meaning that you'll have no zeros. Okay? So the actual key values that you have to look at are the ones that are written underneath or inside the square root, the b squared minus 4ac from the quadratic formula. And this is called the discriminant, as you can see here, the b squared minus 4ac. All right? So if this over here, b squared minus 4ac, is positive, then you are going to use the minus and the plus, and you'll have two solutions, meaning that you'll have, where is it? You'll have two zeros. If this is 0, then the solution is going to be just minus b over 2a, so you'll have just 1 0, okay? And if this is negative, then you'll have just math error, all right? And you'll have no zeros. You'll have a class of exercises in your exam, and that's a 99% guarantee that you'll find one of these, which are more or less like this. Find the values of k for which the following quadratic has, and then could be 2, 1, or no zeros. And you just have to use a discriminant, okay? And you just put it positive, equal to 0, or negative. You solve it, and you find the set of values of that constant for which those conditions are obeyed, okay? So we already know, so we still know those three things: the orientation, the x-intercept, or the zeros. What else can we get is, and this is very simple to get, is the y-intercept. The y-intercept, the point where the quadratic crosses the y-axis, this can be very easily calculated just by substituting x on a quadratic in whatever form by 0, okay? The y-intercept is the value of y when x is 0. So substitute x by 0, whatever comes out of that is going to be your y-intercept. So you already know 3 points and the orientation. What is the last point that you need? That is the vertex. The vertex of the parabola, either the smallest point in an upright parabola or the biggest, the highest point in an inverted parabola. That's the vertex. That's also the point whose x-coordinate divides the parabola in two equal sides, symmetrical, right? And how do you get the coordinates of the vertex? That's the importance of the completed square form. There are other methods that involve differentiation, and you will learn this when the time comes in a chapter of differentiation. But if you just do the completed square form, you automatically will have the coordinates of the vertex, particularly if you have the completed square form on this form, okay, in which you have the a outside of the brackets. And then, whatever this is, on my previous lesson, I called this A, B, C, D, F, G, or no, A, B, C, D, E, F. D, E, F, here I called A, B, C, but note that this A, this B, and this C, these are not these A's, B, and C's. These are just to represent the fact that these are numbers, okay? So having said that, what is going to be the coordinate of the coordinates of the vertex? You just have to minus whatever you have there for the x coordinate, and this is going to be your y coordinate. So let's say that this is 2x plus 3 plus 4. So 2x, 2, open brackets, x plus 3, close bracket, square, plus 4. So your A is 2, your B is 3, your C is 4. Then the coordinates of the vertex will be minus 3, 4. As simple as that. And that's probably the main reason why you would want to do the completed square form. Another one would be to get the inverse, and more on that later. So these two things, getting the inverse and getting the coordinates of the vertex, the main two reasons why you would want to complete a square in a quadratic. So with all this information, you can plot the 4 points, the vertex, the x-intercept, the y-intercept. You know the orientation of the parabola. You have enough information to make a very good sketch, almost a drawing of the parabola. What can we say about the intersection of a line with a parabola? To be honest, not much more than what you already know from the previous chapter. It's the same thing, actually. You have a curve, you have a straight line. How do you get points of intersection? You have two options. If you have the quadratic written like this and the straight line written like this, y equals something and y equals something, then the simplest method is just to equal this to that and just solve. All right? In this particular case, that's what I just did. I solved it. So I have here the two solutions, x equals 0, x minus 1. To get the corresponding values of y, just substitute these 2 points on either one, the simplest one, usually the straight line, because they, by definition, these are the points where they are the same, and get the corresponding values of y. All right? If they are not written like this, and if you don't want to bother to write them like that, you can just use simultaneous equations, right? So imagine that now the equation, the parabola, is written like this, and the straight line is written like this. Don't bother turning them into that. Just do simultaneous equations. And the advantage of using simultaneous equations is that you will have automatically both coordinates of each point. If you want to do the intersection of a parabola with a circle, it's basically the same. Here you will only use the simultaneous equations because you cannot write a circle as y equals something, but that's it. You just plug in here the two equations and solve it. There's nothing specific or more problematic about that. What about inequalities? When it comes to inequalities, I like to teach just the method that I learned back then when I was a student, and I think it is the simplest one. Okay, let's say that you have a quadratic, and now you don't have it as an equation, so equals to 0. You have either is bigger or smaller, or bigger than equal, or smaller or equal to 0. Okay, this is what you have to solve. This is my method. So you stop right at the beginning, and you can do, like inside brackets or something like that, you can just change temporarily this sign, whatever it is, to an equal. So you are going to turn basically the quadratic inequality into an equation. And you solve it. Okay? You solve it. You are most definitely going to get two numbers. All right? And the roots. So what do you do with the roots? You draw a line and you plot those two numbers. On the left, the smaller, on the right, the biggest one, and that's it. Then you look at the coefficient of x squared just to see if it is positive or negative. If it is positive, just draw something like this, a little sketch that passes through those two numbers, something like this. If this is negative, something like this. Okay? And then, and only then, you are going to look at whatever sign you have there. So let's say that you have bigger than 0, so positive. Look at your sketch and look what part of the parabola is on top of the line. On top of the line means that the parabola is bigger than 0. If the sign is negative, just look at the part of the parabola in which that is underneath the line. I'm going to use an example to explain. So let's say that this is the thing that you need to solve. Just pass sorry. Just pass the -8 to the left hand side, and now stop over there and turn this into an equation. In this case, I just factorized it, and I have these two roots, 2 and 4. Then, little sketch, little line, just draw 1, 4. Look at the orientation of the parabola. The coefficient of x squared is 1, so it's positive. So I write something like this. And now I'm going to look at what the question was asking me. This was asking me, using math language, for which values of x is this parabola smaller or equal to 0. And now that I have here the simplest sketch possible that allows me to answer that, I can provide the answer. This happens when x is in between 2 and 4, including, okay? Including, okay? If this was just smaller than, then here I would take that little line as well. If this was positive, then it would be all values of x until 2, so x smaller or equal to 2, and x bigger or equal to 4. I think that this method is simple enough, doesn't involve any other calculation than what you already knew, basically solving equations, then drawing a sketch that takes less than 2 seconds to sketch, and just interpreting it.